800 kilometers above your head, a cone of aluminum weighing 112 kilograms has been falling around the Earth since May 2013. It held a satellite once. It let go and stayed. Europe picked it out of 40,000 tracked objects and built a mission to go and fetch it, the first piece of junk humanity would ever take back. In August 2023, before the ship existed, something hit it.
Start with the scale, because the scale is what makes this feel hopeless. Radar and telescopes on the ground currently track about 40,000 objects in orbit. Roughly 11,000 of them are working satellites. Everything else is dead. Spent stages, dead payloads, bolts, lens caps, frozen coolant, paint. Below the size a radar can resolve, the models take over, and the European Space Agency's models estimate around 1.2 million fragments between 1 and 10 centimeters across, and something near 130 million smaller than that. You cannot sweep that. There is no net that big. There is no magnet, no vacuum, no broom. And here is the part that rarely survives into the headlines. You do not have to. In 2010, two NASA researchers, J.C. Liu and Nicholas Johnson, ran the collision models forward 200 years. They found that low orbit could be held roughly stable if you removed about 5 large objects a year. 5, not 5 million. The whole question collapses into a much smaller one. Which 5?
In 2020, a researcher named Darren McKnight did something unglamorous and extremely useful. He collected 11 separate rankings by 19 authors, different methods, different assumptions, and merged them into a single master list of the 50 statistically most concerning derelict objects in low orbit. The top 20 entries are all the same object, not a satellite, a rocket stage, the SL-16, the second stage of the Soviet and then Russian Zenit 2, launched between 1985 and 2007. Each one is about 11 meters of empty aluminum tube, weighing roughly 9 tons, and many of them are tumbling, which observers can see in the way the brightness pulses as flat surfaces catch the sun. They cluster near 800 kilometers, one of the most crowded bands in orbit, on paths that will not decay for centuries. McKnight's estimate is that removing all 50 would roughly halve the risk of new debris being generated. The top 10 alone would cut it by about a third. So the list exists, it is public, it is ranked. Nobody has been.
What has been tried is real, and it is smaller than the coverage suggests. In September 2018, a British spacecraft called Remove Debris ejected a small CubeSat, let it inflate a 1-meter balloon, waited until it had drifted about 6 meters away, and fired a net over it. The net worked. In February 2019, the same spacecraft fired a harpoon at 20 meters per second into a panel of satellite material held out on a boom 1.5 meters long. That worked too. In 2021, a Japanese company, Astroscale, flew ELSIDAD, which found and docked with a target using a magnetic plate, a plate that had been bolted to the target on the ground before launch. Then, in 2024, the same company flew ADRAS-J, which located an abandoned Japanese H-2A upper stage that had been drifting since 2009, photographed it, flew around it, and close to 15 meters before the onboard software aborted the approach on its own. Look carefully at all of that. Every single target was either cooperative or was never touched.
There is one mechanism that has removed thousands of objects reliably for 70 years, and it is free. The atmosphere does not stop cleanly at some line. It thins out and keeps going, and at 400 kilometers, there is still enough of it to drag. That is why the International Space Station has to be pushed back up. Left alone at that altitude, a satellite comes down in a couple of years. At 800 kilometers, the same object stays for centuries. And the atmosphere is not steady. When the sun is active, the upper air heats and swells, and the drag increases, sometimes suddenly. In February 2022, SpaceX launched 49 Starlink satellites into a low insertion orbit, and a geomagnetic storm hit while they were still climbing. 38 of them never made it up. They came down within days. So the honest first answer to how you remove space debris is that you get it below roughly 500 kilometers and let physics do the rest. The problem is where the dangerous mass actually sits.
Here is the part that almost no video on this subject spends time on, and it is the actual reason the list of 50 has never been touched. In 1967, the Outer Space Treaty was written. Article 8 says that the state which registers an object in space keeps jurisdiction and control over it and ownership of it wherever it ends up, in orbit or after it comes back down. There is no clause that ends this. There is no point at which a satellite becomes abandoned. A dead rocket stage tumbling since 1987 is still legally the property of the state that launched it, and going up and grabbing it without permission is not salvage. It is interference with another state's space object. You have seen the animations of a claw closing around a derelict. What the animation never shows is the paperwork. This is why the European mission changed targets after its own was struck. It no longer goes for an orphaned adapter. It goes for Proba 1, a satellite the agency built, launched, and still owns. Easier to catch, impossible to argue about.
And the reason permission is difficult is not bureaucratic. It is that a spacecraft which can find an uncooperating object, match its tumble, and take hold of it is by definition a weapon. There is no engineering difference between removing a dead rocket and removing a live reconnaissance satellite. The capability is one capability. In January 2022, commercial telescope operators watched a Chinese satellite called Shijian-21 approach a defunct Beidou navigation satellite in geostationary orbit, dock with it, and tow it several hundred kilometers up into the graveyard band above, then return to its own station. China described the mission as a test of debris mitigation technology, and by any technical reading, that is what it demonstrated. It was also, to a large number of military analysts, a demonstration of something else entirely. Both readings are correct at once, and that is the trap. Every nation that could clean up orbit is watching every other nation's cleanup vehicle and seeing a tow truck that can also repossess. Which brings the whole thing back to the 50 objects, and who owns them.
The strongest case against all of this comes from inside the field. Liao himself later cautioned that removing 5 objects a year was notional, a benchmark for planning, not a promise, and calibrated to an environment that has since changed enormously, because the dominant object in low orbit today is no longer a derelict. It is a working satellite, one of many thousands, maneuvering. Plenty of specialists argue that a single removal mission costing tens of millions to fetch one dead stage is money that would prevent far more debris if it were spent on making new launches dispose of themselves. And there is a cost to removal that only recently got measured. Everything you deorbit burns, and burning aluminum produces aluminum oxide, which is a known catalyst for the chemistry that destroys ozone. A 2024 study in Geophysical Research Letters estimated that a typical 250-kilogram satellite generates roughly 30 kilograms of it, and that satellite re-entries in 2022 raised atmospheric aluminum by around 30% above natural levels. Removal is not deletion, it is relocation, downward.
So the answer to the question, as of today, is this. We know exactly which objects to remove, and roughly how many a year it would take. We have flown nets, harpoons, magnetic plates, and drag tethers, and they work. We have flown to within 15 meters of a real derelict and taken its picture. And in 70 years of spaceflight, not one abandoned object has ever been captured and brought down by another spacecraft. The obstacle was never the grabbing. It is that everything up there belongs to someone, forever, and the machine that would fetch it back is the same machine that could take something that still works.
That cone is still up there, spinning a little faster than it used to, waiting for a ship that has not been built yet. If you like the ones where the problem was solved on paper decades ago and remains entirely unsolved in the sky, that is most of what gets made here. There is a long list of them.